In our next section, we're going to look at using OSPF as the PE to CE routing protocol for L3VPN. And we'll see that OSPF has a bunch of caveats in terms of the design of the areas, as well as the path selection and the loop prevention that we need to make sure we understand both the operation on regular iOS and in iOS XR. Now, if we take a look back at our current topology, right now we have in the MPLS core, we have routers 1, 2, and 3, as well as XR 1, 2, and 3, running both ISIS and LDP. We have XR1 running as a VPN v4 route reflector, as well as router 1 running as a VPN v4 route reflector. And then we have two separate VRF sites. We have site A that is on XR1 and router 1. We have site A that is between router 3 and router 7. And then we have site B that is on router 2 and 10, XR1 and router 8, and then XR4 and router 3. So first, let's look at just basic OSPF configuration in terms of the PE2C routing. We'll look at it in a correct functional design, and then talk about what are some of the things that we can run into in terms of problems with the OSPF PE2C routing, and then what are the particular resolutions for those. So first, we're going to start between router 3 and router 7, looking at our regular iOS configuration. And we'll see that this is fairly straightforward from a basic OSPF version 2 config point of view, where we could either go under the OSPF process and then issue the network statement in order to turn the process on. So we'll say just network 10.0.0.0, 255 is in area 0. And then we'll also say we want to do read-to-be connected for our loopback interface. Okay, read-to-be connected subnets. Okay, from router 3's point of view then, we're simply going to go to the link level that is connecting to the customer edge, which in this case is interface gig 137, and just enable OSPF at the link. We'll say IP OSPF 1, area 0. Okay, same is going to be true between routers 1 and 5. So on router 5, we'll say that under OSPF 1, we want network 10.0.0.0.255.255.255 is in area 0. And then we'll do redistribute connected. Okay, we're redistributing our loopback. And let's say show run router OSPF. We'll take this same config, and then we're going to apply this on routers 4 and 6. 4 and 6. Okay, from 1's link down to router 5, as opposed to configuring this at the link level like we did on router 3, we're going to first go to global config and define the OSPF process. So globally, we're going to say router OSPF 1. But one of the differences here in terms of enabling the OSPF process is that we need to specify what is the routing table, what is the VRF, in global here when we're defining OSPF as opposed to under the process. So what this means is that when you have multiple VRFs and multiple OSPF processes, that you're going to be running separate copies of OSPF as opposed to like BGP or EIGRP, where you have one process total and then you're specifying the individual VRFs under the sub-process. So here we're going to run process number 1. It's going to be for VRF A, and then we can issue our network statement. So in this case, we'll say 10.151, so the exact match, and that interface is going to be in area 0. Okay, we can see we have the adjacency with router 5, and then from router 5's point of view, if we look at the show IP OSPF neighbors, we should see adjacencies with 4 and 6, and then likewise from 6 we should see adjacencies with 4 and 5. So show IP OSPF neighbors. Okay, adjacencies are up. Okay, next we're going to do this on XR1. So on XR1, we're going to have one global process. So we'll say router OSPF 1. And under this, we're going to then specify the VRF. In this case, VRF is A. We're running area 0, and then the specific interface is going to be gig 0000.411. So same type of configuration as we did previously in OSPF. The only change here is that we're specifying it's in a different routing table. It's in VRF A as opposed to being in the global table. Now again, there are multiple levels of inheritance for the OSPF hierarchy, where we could say that this specific interface is in area 0, or we could say multiple interfaces are in area 0, as long as when we look at the show OSPF 1, for a VRF-A interface brief, and we see that the process is configured and we have the area on the interface, that's essentially what the final goal is. So the area could be above the interface, the area could be below the interface, we could have multiple levels of inheritance, but again, as long as we have it enabled, that's what the basic goal of the process. Okay, next if we look at the show OSPF 1 VRF-A neighbors, we see we have the adjacency with router 4, and if we look at the show route for VRF-A, we see that we have some OSPF internal routes, and then we have those loopbacks that we were doing the redistribution of. Okay, also let's go ahead over to router 6, and I'm going to undo the redistribution here under OSPF, and I'm going to advertise the loopback with a regular OSPF statement. So let's go to loopback 0 and say IP OSPF 1 area 0. Okay, this should now mean from the provider edge router's point of view, they're going to see this as an internal OSPF route. We have O as opposed to OE2. Okay, now we've already established reachability through the MPLS core. We already have our VPN v4 peerings up. So the final step is going to be to do redistribution from the PE routing, PE to CE routing into VPN v4 BGP. So specifically here in iOS XR, we're going to go to router BGP1. Our VRF is A. Address family is IPv4 unicast, and we're going to redistribute OSPF1. Okay, likewise, under the OSPF process, we have for VRF-A, we're going to redistribute BGP1. Okay, we'll commit the config, and then we'll have a similar configuration on router 1 and router 3. So on router 1, we'll say that under router BGP1, address family is IPv4 VRF-A, we're going to redistribute OSPF1, and under OSPF1, redistribute BGP1. Now notice in this case I don't have to reference what is the VRF name, because once we create the process as VRF aware, every time we reference it afterwards, it's assuming that you're talking about the VRF aware process as opposed to global. So when we look at the show run section OSPF, process number 1 is VRF aware. Okay, let's go ahead and say the same thing on the other side on router 3. So we'll say under router BGP1, we have address family IPv4 VRF-A, redistribute OSPF1. Under OSPF1, redistribute BGP1. And I should have said subnets on router 1 as well. Let's say show run section OSPF. Should have said that. Actually, I did say subnets. Okay, so now let's check, did we actually originate the VPN v4 routes? So from router 1's point of view, let's look at the show BGP, VPN v4, unicast VRF-A. And we can see that we have loopbacks of 4 and 5 as well as 6's loopback. Okay, if we go to the other end, let's say we go over to router 7, and from 7 we look at the show IP route. We can see that we have not only the loopback of 4 and 5, but also the loopback of router 6. And notice that the encoding of these is different, that the routes that were originally external routes are staying as external routes. The route that was intra-area on the other side now becomes inter-area because of a special encoding in the BGP extended communities that tells these devices that they're in the same OSPF domain. So specifically in this case, if we were to look at the show BGP, VPN v4 unicast all for the prefix 6666/32, actually on, that would be on, not on 7, that would be on router 3. Okay, under router 3, we should see that we have the imported path, and it says that in the extended communities, we have this OSPF domain identifier, which is going to say that they're in the same, from the same OSPF process. Okay, we'll come back to this in more details in a couple minutes, but basically where this number comes from is what the OSPF process number is by default. So notice here where this is being originated from. This route came from 1111. On router 1, if we were to look at the show OSPF 1 or show IP OSPF 1, it says that OSPF process number is 1. The domain ID has a value of 0001. Since the process number that I used on router 3 is the same, if we show IP OSPF 1, it implies that the domain identifier is the same, and we can do the encoding of the intra-area routes as inter-area routes. Now, like I mentioned, we'll come back to that in a minute, but let's just look at now the basic connectivity to see whether we have reachability between the neighbors. So from router 7's point of view, let's go ahead and do a ping to 6666, and we'll say source this from our loopback. Okay, so some sort of reachability problem. Let's see, well, what happens if we source this from just our regular interface? Okay, in that case, we do have reachability. Okay, before we look at the rest of the MPLS in the middle, let's take a look at router 6 and see what does it know about the remote site. So from 6's point of view, let's look at the show IP route OSPF. And what do we see that's significant here about the remote site routes? Okay, we know as an internal path, we know the link between 1 and 5. We know the link between 4 and XR1. Okay, we also know the link between 4 and 5. We know about the link between 3 and 7, which is this one. And we're seeing this as inter-area. We see the link between 7 and 13, okay, which is this one. We see that likewise as inter-area. But what we don't see is the loopback of 7. Now, from router 7's point of view, when we show IP route OSPF, we see the loopbacks of 4 and 5 as external. We see the loopback of 6 as inter-area. We see the links between 1 and 5. So here, 4 and 5, 4 and 6 is external. So 4 and 6, we see this as external. We see this one as inter-area. And then between 4 and 11, okay, so let me clean this up a little bit. So we're talking about from router 7's perspective, it sees 4's loopback as external. It sees 5's loopback as external. 6 loopback as inter-area. The link between 1 and 5 and 4 and 5 as inter-area. The link between 5 and 6 is inter-area. And the links between 4 and 6 and 4 and 11 as external. So what's different about how these prefixes are being announced? Okay, we have two different routers that are doing redistribution. We have router 1 and XR1. Same type of configuration under OSPF and BGP though. We're just doing basic redistribution. We're not doing any type of route policy. We're not modifying any other options. But clearly there's a default behavioral difference between them, right? Because when we look at what are the routes that XR1 is announcing, like this link, we see this encoded as external. But the directly connected link between 1 and 5, we see this encoded as inter-area. But from 6's view, the other direction, we don't see the route to the loopback of 7. Now, this actually has to do with a couple of different unrelated options of OSPF. Okay, one is that in regular iOS, when we redistribute OSPF into BGP, regardless of whether it's in the global table or in the VRF table, we only include intra-area and the inter-area routes. We do not include external routes. And where we would see this specifically is on router 3. On router 3, if we were to look at the show BGP, VPN v4, unicast, all, and look at what routes that we are locally originating. Okay, so not the ones that are coming from the iBGP peers, the ones that are local. So let's say pipe exclude the lowercase I routes. We see 3.7 and 7.13. Okay, 3.7 is this link here. 7.13 is this link here. From router 3's point of view, when we look at the show IP route for VRFA for OSPF, we see this link 7.13 as an intra-area path. The other one, 3.7, this is a directly connected route. So those two are getting advertised, but not the external prefix, because again, in regular iOS, when we redistribute from OSPF into BGP, we only include the intra-area and the inter-area routes. What we would need to say to fix this is under BGP. Okay, and also, as someone had asked here, right now there's no different areas. Everything is just area 0. So it's area 0 behind router 1 and XR1. It's area 0 behind router 3. Okay, so what I would need to say here on router 3 is that when I redistribute OSPF into the BGP process, I need to make sure to also include the external routes. Okay, so this is the first difference. On router BGP1, we'll say redistribute OSPF 1. We need to match the internal and the external routes. Now, if router 3 was also in a not so stubby area, we would need to say NSSA external, but in this case, we don't have any type 7 LSA. So, okay, this is one. We need to match the external routes. Now, from router 6's point of view, now we see the external path. It says I have two different ways to get there. I can get there through router 1, or I can get there through XR1. Okay, if we now do a ping to 7777, source from router 6, okay, we're able to reach it. Okay, if we do a trace route to this, we should see that there's multiple possible exits. We can go to router 4 or router 5. From there, we can go to router 1 or router 11, and then we have multiple paths over the MPLS core. But notice what's always the same about the destination. We're always using the VPN label number 29 because that's coming from the VPN v4 advertisement of router 3. What is different, though, is what is the transport label that we're using. Sometimes when we go to router 11, we're using, let's see, 10, 1, 11, 1. We're using 17 here. The other option is that we're using, well, technically it's the same label number, but it's on two different hops. Okay, from the way back, if we look from router 7, and let's do a trace to 6666, sources from our own loopback, it says we're going from 3 to 2 to 1 to 5 to 6. So specifically, we're going 3, 2, 1, 5, 6. But from 2's point of view, we do also have an equal cost path in order to get to that PE router. Okay, let's try the other ones. Let's do a trace to 4444. Sources from loopback 0. This one we're going from 3 to 2 to 1 to 11. So 3 to 2 to 1 to 11, and then to 4, where router 1 could have also gone that direction, but instead we're redirecting the traffic this way. Okay, let's try 5's loopback. This one is doing the same thing. We're going from 7 to 3, 2 to 1, to XR1, to 4, to 6 to 5. So why wouldn't we choose the shorter path in this case? Why would we not go directly from 1 to 5? Okay, let's look at this from the routing advertisement point of view. From router 7, if we look at the show IP route for 5555, it says I know this from router 3. Okay, we get to router 3, we look at the show BGP, VPN v4 unicast, all 5555/32, and it says I have how many paths? I have one that came from router 1, and I have one that came from router 11. But notice what's the same about both of these. The originator is 11. So router 1 is reflecting a route to us here, but it's not a locally originated route from 1's perspective. It's one that's coming in from 11. So if we were to go to router 1 and look at the same output for this, what this is showing us is that 1 did not do this redistribution. It's learning it from the other provider edge router. And again, the reason why, when we look at the show IP route for VRFA, is that from router 1's point of view, these routes are installed as OSPF external, which means that when we redistribute from OSPF into BGP, we only include the internal routes. So just like we did on router 3, we're going to need to go to router 1, and we're going to say under router BGP that under BGP 1, under the VRF, redistribute OSPF 1, and we need to match both the internal routes and the external routes. Okay, once we do this and then we look back at the BGP updates, we should see now that we have a locally originated one, so we're sourcing this route locally. And we should see now that both of these get reflected to router 3, but they're going to be coming from 2 different routers. So this one is from 1111, this one is from 111111. Now we're choosing the one that, that came from router 1. Okay, the reason why is that from an IGP metric point of view, we are closer to get to router 1 versus 11. And I believe this has to do with some of the interfaces being shut down in the transit path. If we look at the show IP interface brief, interface 312, which is going this way, is disabled. Okay, so let me enable that interface gig1 312. And then I think that router 2 also has some ports disabled too. Okay, interface gig1 211, 212, and 213. So this means for router 3's point of view, when we now look at the BGP updates, we should see that they're both an equal metric. And I want to say that we're choosing router 1 because it has the lower router ID. Okay, if we then look at from 7's point of view and show IP route OSPF, we see that we have the inter-area route in order to reach router 6's loopback, the external routes for the loopbacks, and then notice here still that we have the external routes in order to reach this interface here and this interface here. So these two are external, where these two are inter-area. So why would the encoding be different of these if we're not advertising them any different in terms of OSPF? From router 4 and 6's point of view, we have the same exact config as we do on router 5, so we're just enabling OSPF everywhere. So on router 6, if we look at the show IP OSPF interface brief and show run section OSPF, we're not doing redistribution here. We just have the OSPF network statement configured. Okay, the updates go over to router 4 and 5. If we look from 4's point of view and show IP route OSPF, we see that we have the intra-area routes, which are 5.6, so this one here. And then we have these other 2 links as connected. When we look at this from XR1's point of view and show route for VRFA, we see 4.6 as an intra-area route, which is basically the same as what router 1 should say. So let's say show route VRFB or show route VRFA for 10.460. This is intra-area. Let's look at this from 1's point of view. Show IP route for 10.460 in VRF A. So it's intra-area on router 1, it's intra-area on XR1. So why on the other end then, okay, the other end being router 7, why would router 7 be seeing this as an external route? Okay, let's look at this from router 3's point of view, the one that's actually doing the advertisement of BGP into OSPF. If we show BGP, VPN v4 unicast for 10460/24, what's one of the differences between these two prefixes? Okay, this one came in from router 1, this one came in from 11. We have the local preference of 100 for each of them. We have a lower metric value for this path versus that path. So remember when we talked about our path selection order. Okay, the order we said was that we have the weight, the local preference, AS path, origin, and then the med. Okay, after med, we go to the IGP metric. Okay, that's to the next hop. Actually, before that, there's eBGP over iBGP. But in this case, we're not even getting that far in the decision process. Okay, there's a difference in the med between them. So the med of 3 versus the med of 2, this is the reason why we're choosing that as the best route. So think about in terms of where the devices are in the OSPF network. From router 1's point of view, it's one hop further away from this particular segment than XR1 is. So from XR1, we're saying it's a cost of 1, it's a cost of 2 to get there. Router 1 is saying it's a cost of 1, 2, 3 to get there. So that's what's being encoded in the BGP med. But why would we be encoding this as external as opposed to internal? Okay, what else is different here in terms of the VPN v4 update? So we saw the med was different. We have the extended communities. Router 1 is saying the route target is 100:100. Likewise, XR1 is saying the same thing. We have the OSPF route target, which says basically what area it came from. Okay, it came from an LSA2. But notice in the extended communities, XR1's not advertising the domain ID. Now, this has to do with the path selection order in terms of the type of route and how we encode the OSPF route into VPN v4 and how it's going to come back out on the other end. Now, as I mentioned, the OSPF domain ID comes from the process ID by default. So if the process ID is the same on both sides, the domain ID is the same on both sides, and it means that an intra-area route on one side is going to appear as an inter-area route on the other. Okay, this is why from router 7's point of view, when we look at the route for 6's loopback, we see this as intra-area. Because from router 1's point of view, when we show IP route for 6666, this is an intra-area path, actually in VRF-A. This is intra-area. This means when we convert this into a BGP update, we say it's an intra-area route, which is what the OSPF route target says. And then we encode what actually this one here. Okay, then we encode actually I think it's the route type, not the route target. We encode the domain ID, which in our case is coming from process number 1. It gets to the other side, and router 3 says, well, it depends on what the best route is. Let's look at BGP and say, for this route, we're choosing router 1 as best. Okay, so when we do the conversion, we're taking that domain ID. If it matches the local process, we're encoding it as inter-area. But in the other prefixes case, we happen to choose XR1 as the best route, not as router 1, and the domain ID is not automatically being encoded. So the key difference here is that in regular iOS, the domain ID gets encoded by default. In iOS XR, it does not. Now we can configure it to do that, it's just that it doesn't automatically inherit it from the process ID. So specifically to do this on XR1, what we would need to do is if we look at the show run router OSPF, we'll say for router OSPF1 under VRFA that the domain identifier, the type is going to be 0005, and then the value is going to be 6 octets in hex, which would be 0 by 0000 001. 6 octets, that's 1, 2, 3. No, that's not enough. It's going to have to be, let's look at what router 1 is using. It would be this. So that is how many bytes? 1, 2, 3, 4, 5, 6. Okay, 6 octets. Okay, if we then, let's go ahead and commit our changes. And if we look at the, oh, it failed. Failed to commit, please issue the show config fail. Domain ID size is wrong. Okay, let me try it without the 0 by X. Let's say abort. Then we'll say it is that value. Okay, so it wants it without the 0x. If we now show BGP, VPN v4 unicast for VRFA, and let's look at the prefix 6666/32, we should see now 11, which is us locally, is now also encoding the OSPF domain ID. So this means that when router 3 chooses this route as best, it now has the route encoding. And if we look at how this translates into OSPF, we should see that these two prefixes here are going to change from external to inter-area.